So you're going to be my class. So what we're going to do an experiment called the Cartesian Diver. So I'm going to show you how to prepare the experiment. You're going to have a bottle, which you have. Do you all have a ketchup package?
Yes.
Okay. And you have a top.
Yep.
So first thing you're going to do is stick your ketchup package in the top of the bottle like that. Awesome. And you fill it up with water to the very top. And your ketchup package should float.
Does it matter that it's packaged? Does it matter that it's ketchup?
Well, that's a good question. We'll ask that question. Just a moment. You have pieces of paper right next to you, and you can write down questions that you have about that, because I'm going to ask you to form a hypothesis about the observations you make about the phenomena you will witness. I wish this would go faster.
Well, it's paper.
You should have your own book.
There was a book there. Nope.
Yeah, there's 3 books. You need to come to class bringing your materials. Make sure this is screwed on tightly. Thanks. Okay, head of the class now.
Thinking about it.
The name of the experiment, the Cartesian Diver, should give you some suggestion as to what's going to happen. There you go. Where's the other cap? Do you stand with a cap?
Oh, where's my caps?
Where's your cap?
Oh, there we go. Oh, that's here. Danger.
Okay. Pay attention, Mr. Rose. Screw that on. They're all floating. That's the Cartesian Diver, see? It's pretty cool. Now you have to explain what I'm doing, form a hypothesis about what I'm doing and what phenomena is going on and why you think it's happening. And you can try to make yours do that. Have you tried it? So first, describe you think you know what I'm doing. So first, describe the observation. What exactly are you witnessing?
Well, the packet is falling to the bottom,
And
and it's floating back up at a more rapid rate than when it fell.
interesting. Okay. And how do you think that's being managed? What do you think is causing?
Are you asking me?
I'm asking anyone.
Well, I think it's because we're
First of all, what are you doing to the bottle? Because you're making it happen.
we're compressing it. We're compressing the water in the bottle.
Okay. Sometimes it doesn't work unless there's absolutely full bottle. Just want to take as much air out as possible. There, I've given you a clue. Yours may not work, monkey.
Is it because I'm a bad kid?
It's not because you're a bad kid. Try.
You're going to get that question, you know.
I understand.
I don't remember. It's because we're increasing the density of the water in relation to the ketchup packet.
Are you increasing the density of the water? Well, first of all, each of you explain what you think is happening, or what it is you're seeing.
Or not so much the density.
Or the pressure?
Yeah, what we're seeing is as we increase pressure, that the object becomes less buoyant in this situation.
Okay, so what do you think is particular about either the bottle, what's inside of it, or the ketchup packet that's making it go up and down when you exert pressure?
Difference in volume.
Difference in volume in?
Volume in or and?
Well, difference in volume in what particular object or part of the experiment?
The water's volume is changing.
The water's volume is changing.
But the ketchup packet is not.
Okay.
So in its resting state, it is only so dense that it falls beneath the water. But when we increase the volume, since the ketchup packet stays the same.
How could you test that?
How could you test that? Test that that's happening?
Test your hypothesis.
That
Suppose you emptied out some of the water and you decrease the water volume. It's still occurring. So do you think it's the volume in the water, or do you think it's the volume in the ketchup packet?
I guess it's the volume in the entire bottle.
Volume in the entire bottle. Why do you think the ketchup packet is floating? You seem to have a defunct.
It's not because I'm a bad kid.
It's not because you're a bad kid.
Give us
So
the
explain
base,
to me,
is it the base?
why do you think the ketchup packet is floating in the first place?
Because its contents are lighter or less dense than what's in the water.
When it was packaged, what do you think was probably included
Sugar,
in the package? That's an ingredient.
salt,
What else that's not an ingredient?
Air.
Air, exactly. So you probably have an air bubble. So the density of the packet is greater or lighter than that of the water.
It's less.
It was less, which is why it floats. Do you agree?
Yes.
Okay. So what would squeezing, what would applying external pressure do potentially to the ketchup packet to make it sink, and then when pressure is released, make it float back up?
could add pressure to the water, and then the water, that pressure adds pressure to the ketchup packet, and so it squeezes the contents of the packet together more than they were before.
Excellent.
To make them more dense.
Make it more dense. So what's the formula for density?
D equals M over V.
Okay, which would be density
D equals
is
mass over volume.
So when you exert external pressure, which gets exerted on the ketchup packet, what do you think is happening to the volume in the ketchup package?
It's lessening.
Which would decrease its density.
Is anything happening to the ketchup packet, or does it have to do just with the water?
Well, it has to do with the ketchup packet because you're decreasing the volume in the ketchup packet, which is making it more dense. So it's denser than the water. So it floats, or rather it sinks. But when you release the pressure, the bubble inside the ketchup package becomes, it has greater volume. And so its density decreases, and so it floats to the top. It becomes less dense than the water around it.
Because
Okay.
how does it actually change?
It changes because when you apply the pressure, okay, you're applying it externally, and that's putting pressure on the water package.
You mean the
it's
ketchup packet?
the catch package, yes. So it's decreasing the volume. You can't decrease the mass, but the density will increase as you decrease the volume. So you're making it more dense than the water around it.
Okay.
Does that make sense?
Yeah.
Is that what you had written down?
I wrote increasing the density of the water by reducing the volume. But no, that's not the case. So what I was thinking is that it's an effect of the water changing rather than the packet. But now I see that it's in how this whole container of water affects an object inside of it.
Excellent. You get an A. You get an A for effort. I don't know why this isn't working for you.
What is it called? Cartesian?
Cartesian, it's called Cartesian after René Descartes, the French mathematician. Do you remember Cartesian points in mathematics?
Vaguely.
He's a great mathematician and
Like
philosopher,
Euler.
and he developed a number of experiments. However, Descartes would be very upset with this one.
He feels
How did they do it?
because he's dead.
Yeah, he didn't have plastic, so what do you use?
Well, actually, this originally was used with an eyedropper. When you do a really well done Cartesian diver, you take an eyedropper and you can actually see the bubble of air, and it will float on the top. And then as you decrease, or rather increase the pressure, it will float. Unfortunately, eyedroppers are hard to come by. Really difficult for me.
But they also glass.
They are glass, but it would still work. It actually works more specifically. Ketchup packets are the poor man's eyedropper.
I have 5 eyedroppers.
You have 5 eyedroppers? Well, we could. You're not supposed to say that on camera so that my professor thinks that all I could use is ketchup packets. Sorry, Professor. Wait, there we go.
It's
No?
physically the same thing, isn't it?
Yes, it is. All right. So thank you. You all get an A.
Thanks, Teach.
You're welcome.
I love math.